Do you have challenge in finding people in semiconductor?
India has always been lauded for engineering talent.
It's not lucrative anymore to go outside of India.
India has already established itself as a global player on the EMS market.
We have come up with a very good pool of fundamental subjects.
We're a leader in manufacturing and automotive. All the top OEMs are our EMS customers.
We are seeing some very specific trends in the industry.
Industry gets better talent out of the academia.
We are talking about sustainable solution. We are talking about stable supply chain, things that were disrupted during the COVID.
I don't know how AI will survive without semiconductors.
I can build this unique secret sauce that I have. Put everything on the single package.
Currently in India, around 1.3 lakh design engineers today.
The industries are very closely working with universities.
We're planning to set up COEs at Kaynes.
Spend a lot more time on fundamental knowledge.
The fundamentals then need to be built on into the actual industry required protocols.
For every low-cost geography you have, there is going to be another lower-cost geography.
So now you're seeing electronics parks and manufacturing clusters come up across the country.
For a very long time, we were just a design powerhouse of the world.
CapEx, your development cost of setting up a startup is funded to the extent of 75 to 80%.
So many companies got cream of the crop.
All of this together will propel it to the next stage.
Tired and frustrated of corporate artificial and plastic talks? Are you frustrated with unskilled YouTube gurus telling you what to upskill, how to cross skill when they themselves don't have any tech background? So here at Titan Stock, we call industry stalwarts from across multiple industries and have them share their views on what they look for in lateral candidates and in freshers. So these are people who've been there, done that, and who are continuing to do. So these folks are going to give you their raw, unfiltered opinion on what they want and what they look for in a candidate and how you can prepare. We will talk about how should a lateral approach every industry and how they should get in, and how a fresher should kind of prepare themselves so that they become industry ready and more employable compared to just another college graduate. Welcome to Titan Stock. Here we are with another episode, again breaking the shackles of corporate world and talking to you straight from the heart.
Hey, welcome everyone to Titan Stock episode 3. So today we are going to talk about semiconductors again. But then, I come from a data science and AI background. But then that said, all data science and AI and all fancy stuff happens provided the silicon supports it. And silicon industry has been long forgotten stepchild and not given enough love for what they've done. So we want to talk about the technologies that are evolving in semiconductor and what are the jobs available and how can people make a difference in silicon. So that's what we are going to talk about. So today we have Sharat Kaul.
Welcome everybody. My name is Sharat Kaul. I have about 28 years of experience in design, manufacturing, and software. I'm focusing on areas of high performance computing and the applications of high performance computing and how AI can be applied to high performance computing. Thank you.
Thank you. So Biswadeep, who is AVP-ERS from HCL.
So, like Sharat, I started my journey more than 27 years back. Started with Texas Instruments, worked for a fairly long time with Intel Corporation, with Qualcomm. Out and out a pre-silicon guy, mainly focusing on physical design, automation, high performance computing, and so on. And right now, I'm with, as you said, HCL Tech. I am part of their engineering R&D services.
Got it. Thanks. And we have Shripad from Vishwakarma Institute of Technology. Shripad, a brief introduction about you as well.
Yes, hello, I welcome you all. Yes, I'm Shripad Bhatlawande. I'm professor in electronics and telecommunication engineering at Vishwakarma Institute of Technology, Pune. We are one of the oldest and largest academic group in Pune, and VIT Pune, in our country, NAC and NBA, these are the accreditation bodies. So VIT Pune has received NAC's highest A++ grade, and our majority programs are accredited by National Board of Accreditation (NBA), and NIRF ranking changes annually. And out of NIRF rankings of last few years, the highest ranking achieved by VIT Pune is till now highest NRF ranking achieved by VIT Pune is 64. Well, I did my graduation in electronics engineering from SGGS Nanded. Then I did my master's in digital systems from COEP Pune, and then PhD from IIT Kharagpur. I did PhD in machine intelligence. I worked with Phoenix for a year, and then I joined academics and research. And now I help my students to uh, prepare and develop skill set in core engineering, core VLSI, you may say semiconductor and IT product companies.
Awesome. Thank you very much. So I would like to, understand semiconductor marketplaces with an overview from both of you and then take it from there. Sharat, can you tell me what is the semiconductor industry state in India? Is it all being manufactured outside India, or what is the manufacturing here? What is the design here and all of that?
Sure. Today, we're a net importer of electronics. It's a fact. We have a fab in Mohali, SCL fab. And if you take the entire semiconductor value chain, you have the chip design, and that's broken out into front end and back end. You have the manufacturing, which is again broken out into front end and back end. And then it goes to the systems. Now, if you take a look at this entire value chain, after the success of IT and the voice enabled transcription services, we migrated to software services, which in turn led to basic simulation services for design verification of a chip. That's the front end design. That blossomed and did very well over the last 2 decades. Pioneers like Texas Instruments set up shop here after HP, and then it just blossomed from there, from front end design to even back end design to the entire SoC in India. Today, we can proudly say that India represents around 20 to 25% of the global semiconductor chip design market space in the world. Number one is by far the USA still. More and more advanced chips, in fact, the most advanced chips are done in India by the global captive centers. We are working on cutting edge designs. Indian companies in the front end design space are not on the product domain, but more on the services domain. Then on the manufacturing side, if you were to break it out into front end and back end, front end being the wafer fab, as I mentioned, we have one fab, and we have about maybe, I would say, 7 or 8 R&D fabs doing R&D in the various educational institutions. There's 3 types of major front end fabs, and India is focusing on display, CMOS, as well as compound semiconductors. The digital is what we see in our consumer devices and most of the computing, and compound is more on the power electronics and EVs, and then display, of course, is for the displays. We don't have a display fab, we don't have a compound semiconductor fab, but we have one digital fab at 180 nanometers. Tata has recently announced their plans to do a 91,000 crore silicon CMOS fab in Gujarat at 28 nanometers. There's talks of SCL upgrading to 28 nanometers. And 28, by the way, is nothing to be ashamed about. It's a very stable technology. It has good economics for Indian market. And we can produce the volumes we require at 28. And the 4 nanometers, the 3 nanometers, which are the so-called most cutting edge, it'll take time for India to reach that level, probably a decade. But on the back-end manufacturing, India is very strong. And when I talk about back-end, that can further be divided into the packaging and then to the EMS. India has already established itself as a global player on the EMS market. And when we talk about EMS, or electronic manufacturing services, we're talking about these kits, knockdown kits. We import the kits and then we assemble them. And we use pick-and-place machines and robotics. So Wistron is here, Foxconn is here, Pegasus is here, Tata is getting into very big in ES. Kaynes is we have 22 lines. And then in that you have the PCB fabrication, which we're still a little bit nascent, and we have a lot of growing up to do there. But on the EMS side, we are now the number 2 mobile manufacturer in the world. And now what that represents is an opportunity to go backwards within the value chain. That means that we are going to be a good buyer of the bare wafers, which we're importing today. We'll be able to do this in the contiguous Indian country within our borders sooner, and hand over those wafers within India. The packaging is another area between the wafer and the EMS, which is now emerging in India. Tata has expressed interest in doing OSAT, which is nothing but outsourced semiconductor assembly and test. And this is the area of ATMP, assembly, test, marking, and packing. So once the bare wafer comes from TSMC or Global Foundries or Intel or TI into the country, it has to be chopped up into small squares, put inside the package, and then it has to be put on the board. This is the packaging. And there's a whole area of tests. Now, all of these require ecosystems, believe it. OSAT and packaging requires hundreds and hundreds of vendors. Fab requires hundreds, if not thousands of vendors. Chip design needs universities. It needs design services companies. So all of these ecosystems are now building. And the country has basically started with the back-end manufacturing, low value add, and we're progressively shifting left, adding more value, trying to do more and more downstream value addition and manufacturing. Ultimately, the dream would be to even do the individual components in India, which are all 100% imported today.
Got it. Thank you.
You're welcome.
As in, it was technically very high, but yeah. So coming over to you, Biswadeep, what do you see as opportunities that are available for the companies, especially around the semiconductor design packaging
Sure,
space?
sure. So I think Sarath very eloquently covered the post-silicon part of it, right? And as you know, when we call anything from architectural specification till the point it goes to what we call tape out, as in going to the fab, as pre-silicon, anything post that is post-silicon, obviously. Let me touch upon the pre-silicon aspects of it also, right? As again Sarath mentioned, India has always been lauded for engineering talent. In fact, most of the captives that you see of global MNCs in India, you'll hear about them saying that second largest R&D or the largest R&D center outside US. US being their headquarters, the second largest is here in India. But seldom do we find independent semiconductor product companies being lauded here. Now, that is a trend that we are seeing gradually changing. Thanks to PLI, the production linked incentives and the design linked incentives that the government is bringing in, thanks to C2S kind of initiatives from the government of India, we are seeing a lot of these folks who have spent many, many years in the captives coming out and building their own product ecosystem, building their own companies, right? In the past, the same thing has happened. It's not that this is new, but the focus has hitherto been, let me provide service. Why? For two reasons. One is, if you look at return on investment, service has provided faster returns. You invest in your people, you skill them, you deploy them, and you get a return. Second, the time and the investment taken to build a product is usually way more. Now, with this government incentives, especially around, say, what we call EDA or electronic design automation tool licensing, these are very expensive software, or licensing for IPs, intellectual property, connecting to the fabs that are coming up, the ATMPs that are coming up in India, right? These entrepreneurs are ready to take that leap of faith. It is already there. If you look at rest of the emerging economy, it's already there. For example, IoT, you will find excellent IoT companies in South Korea. You will find a lot of startups in Japan or China who are building alternate material, because these are the need of the hour. We are talking about sustainable solution. We are talking about stable supply chain, things that were disrupted during the COVID. So India has to play catch up here. And thanks to the support that we are seeing from the government, these innovations are happening around product here.
Awesome. Thank you. Thank you very much. So, and then coming to you, Shripad, so I wanted to understand what is academia doing to, kind of bridge the age-old curriculum with the latest industry requirements, and you can also talk about the center of excellences that you've been able to establish at Vishwakarma that are enabling industries to get more ready talent.
Right. So this is really a very important question for academia, and thanks for this question. So basically, what academia is doing, that is, I will stick to what Vishwakarma Group is doing for this. So, Vishwakarma Institute of Technology is strongly aligned with industry and global academia. And for this alignment and outreach, VIT has created a very consistent structure of different boards, groups, and forums. And I would like to share details of all these boards, forums, and groups. We have one board called Board of Studies, so we call it as BOS. So this is a group of eminent academicians and educationists in India and abroad. So for example, in our institute, in our department, specifically I'll stick to semiconductor. So we have professors, senior professors and research scientists from IISc Bangalore, and then professors from IIT Bombay, then IIT Chicago. So we have, as I said, India and abroad professors, and then the local representation is also there from Government College of Engineering Pune, and then Savitribai Phule Pune University, and then our in-house teachers are there. And with the help of this, you can say board, we have come up with a very good pool of fundamental subjects. So we start with basic electronics engineering, then we have semiconductor devices and circuits, then object oriented programming, then analog circuit design, digital design, and then as an elective, as Sharat mentioned, we have RF circuit design also. So RF circuit design is an elective, but we have a good pool of fundamental subjects, and we do very little changes in this fundamental subjects. And if at all any change is required, so in consultation with this BOS, we do that. Then we have industry advisory board. So on our board, we have professionals from Seagate, Cadence, then Marvel Semiconductor, and some other like NVIDIA is again one of the very like important partner of academia, and with their they are into it. So these all professionals are into it, and their experience and expertise help us to design advances, like design subjects or the contents in the advances in semiconductors. So those contents we design with their help. And even like what they share, what kind of challenges semiconductor industry is facing, and what kind of changes need to be done in curriculum, so we understand those things from them. Then we have a forum called Alumni Forum. So our alumni are well placed in semiconductor industries. To name a few industries, Broadcom is there. Then again, like NXP is there, and all other like Cadence, Seagate, Marvel, Alphawave. These are the companies. So we meet once in a semester with our alumni, and we try to understand what changes are happening in industry. And with their help, we design small course project problem statements, even in some cases major project problem statements, and we include those problem statements in our academics. Then we have our own in-house faculty group, and we divided our faculty groups into some special interest group we called SIGs. So we have a SIG of faculty for front-end design, as you mentioned, and then we have SIG in back-end design. And this way, in a very structured manner, they focus on relevant skill set, and they work with some foreign universities, and then the institutions in India like IITs, IISs. They work with them, and they come up with the changes in the curriculum. And as you mentioned, everything cannot be like what brought into academics, and to bridge that gap, we use internships and student exchange programs. So semester long internships is part of our curriculum. So our student go to industry in their semester 7 or semester 8, and they work in those industries as if they are employees there.
Yeah, it's
And
nice.
during this period, they need not come to college.
Right.
Wow. Okay.
So no like what classroom related deliveries there that time. So they are like part of that company. So they work there for a semester, and we send them to industries. Just I named few industries, so we send them to these industries, and then in some cases they go to IITs. And we have a internship program with the Korean Institute of Science and Technology, and then NTU Singapore. So these institutions and these industries have very good facilities at their like premises, and with that help, And here whenever like our student joins any industry as an intern, so we have two level of evaluation. So one evaluation happens at industry and other evaluation happens at institute. So one faculty mentor and one industry mentor is there. And with this, what happens, our faculty members also get exposure, our students also get exposure, and this exposure get reflected into our curriculum. And then we have you can say subscriptions of LinkedIn Learning, and then Coursera, and of course NPTEL. Now government of India has made NPTEL courses available free of cost through Swayam. You may be aware about Swayam, right? So we use these courses. We encourage our student to take at least one course, and faculty members also in a semester. And our faculty members, our students, keeps on tracking the postings of these companies, semiconductor companies, on LinkedIn. LinkedIn Learning is one thing, and then the job posting is other thing. And in almost all jobs, like companies mentioned about the skill sets. So we keep track of those skill set, and we try to include those skill set in our curriculum basically. And whenever we want to revise our curriculum, so we follow this cycle. So we do these revisions in consultation with our BOS, IAB, alumni forum, and our faculty forum. And with global academia, we keep track of global academia as well, how they are changing their curriculum. And with all such inclusions, we keep on revising our curriculum. And more or less, other academic institutes are also doing the same thing. And being leader in that region, basically we help other academic institutes as well. So we are a lead institute in that region, and we keep helping other engineering institutes in that region.
Awesome. That is great. So that's a very helpful way to kind of get the students up to speed in terms of what the industry needs. And but that's very generic, right? So you might have some specific centers of excellences with certain companies, which is more like a finishing school for you guys, so that the candidate is completely prepared on what E&TC is. Once that is done, very specific to colleges, very specific to companies, like say your 1 year internship. So last time when we were talking about it, what I understand is that so you have a center of excellence where the student spends the 3rd year, and then provided he has completed all the credits by 3rd year, the entire 4th year, without any academic commitment, he works at the company like a full-time employee at an internship stipend. At the end of 1 year, you get a 1 year experience candidate at a fresher salary. So it's a win-win for both the student, the industry, and the institution. So wanted to understand what specific partnerships you forge with the industry that you think are helping your students as well as helping the industries get more ready-made talent.
Right. So there are few industries, and we are very closely working with those industries, and one of them is NVIDIA. So NVIDIA, we have a memorandum of understanding with NVIDIA. So NVIDIA conducted a training of almost 100 hours for our students, and they discussed almost all important aspects of semiconductors, and then even computer vision, machine learning. So they delivered all relevant content to our students basically. So they have come up with a very good program for our students. And then what happened, starting from the component design, and then basically the low power design, and then the design for testability, and then the multi-clock design. So they delivered the basic content, basic concepts, as well as they provide exposure on some advanced concepts as well. And because of that, what happened, student could understand the overall ecosystem of semiconductor industry. And then at the end, what happened, NVIDIA recruited few students, and then we have intake of 180 students in Vishwakarma Institute of Technology, Pune. So few students got recruited, means NVIDIA recruited few students, and then after that, several companies come on our campus for campus recruitment. And then what happened, the impact of that training because students were exposed to all the relevant things in the semiconductor industry. So what happened after that? Marvel Semiconductor came on our campus, and immediately Marvel Semiconductor student recruited few students. Then Cadence came, and Cadence also got. And then from that we understood that working with industry is like very much helping our student and our faculty members as well. And we could develop infrastructure with the help of Nvidia. Then there was another company called Aeron Systems. So they are into edge computing basically, and they use ARM and then Raspberry Pi and Jetson Nano related like what edge devices, edge boards,
Hmm.
and based on that, they develop systems around them. And they are into edge computing basically.
Hmm.
So they have set up one center of excellence at Vishwakarma Institute of Technologies, and they supported us for all types of ARM related boards. So they gave us Raspberry Pi boards and Jetson Nano boards, and then some other like portage computing boards. And then what happened? And they did hand holding also, hand holding of students also, just like Nvidia, what Nvidia did. So what happened? So because of that, they gave some problem statements also. Nvidia gave 53 problem statements.
Wow.
Aeron Systems gave around 32 problem statements. So our students and faculty members worked on those problem statements, and because of that, what happened? So students started developing the things and then their deployment on these boards. So the one thing is like what circuit simulation and then the design, and then after that how to put it into a particular embedded system. So they could understand the complete flow of it. And because of that, the skill set of our faculty got improved, students got improved. And because of this ecosystem, if Nvidia is helping, then Cadence is getting benefited. If Aeron is helping, Marvel is getting benefited, and vice versa. So the center of excellence and then the involvement of industry is helping a lot.
Fantastic. That is a nice start. More to that, and then so that the industry and academia collaborate, so that industry gets better talent out of the academia
Right.
compared to a cookie cut E&TC engineer that they'll have to kind of train. So coming back to you, Sharat. So you represent Kaynes Semiconductor Manufacturing, about a 3,500 plus people company which is into semiconductor manufacturing. How do you think Keynes is capitalizing on this growing trend of India becoming a hub for semiconductors?
I talked about the manufacturing value chain of semiconductors and how it's broken up into front end and back end. And I also talked about Keynes as a leader in India today on the back end of the manufacturing on the EMS side. That's the electronic manufacturing services. Once the chip is on the board, and then they put the chips on the board, and they also do end box builds. So, for example, they're doing the 3000 CDAC Rudra supercomputers for the country. It's very logical once you're in that dominant position after a very successful IPO to look at the adjacencies on the value chain, upstream and downstream. And so you start asking yourselves, what are the necessary inputs that I'm currently importing or buying from outside that I can do it myself? So now we're on an aggressive expansion plan on bare PCB fabrication. So instead of importing them from Taiwan or Korea or from India for that matter, we want to make them ourselves. Totally different than EMS, right? It requires a lot of chemicals and acids and the bare boards, copper plating, etc. So we believe this is a very strategic approach for the future, for the next decades to come, and to build high quality, multi-layer, advanced PC boards with through vias, with advanced technologies for the IoT market and computing market. Number two, as I mentioned, the packaged parts come to us on tapes and reels and on trays. Then we thought to ourselves, in addition to the bare PCB which we're putting these chips on, what about the actual package that goes on each and every one of those components? And the government scheme has come up with the PLI scheme to promote manufacturing of downstream components. So we put in our applications with the Indian Semiconductor missions. We will get approved shortly. We've also put in our applications at 3 states, and we're awaiting the approvals from the states. Once the states decides, we're going to make a decision. But That doesn't stop us. So what we've done is we've built infrastructure in all the 3 states, and we're waiting for the approval, and then we'll do the OSAT. If we don't do the OSAT, we'll do the EMS, because we're on such an expansive growth rate. We can't make enough of these plants, these factories. So on the OSAT side, uh, we will take the die from the outside of the country, from TSMCs, UMCs, SMICs, the global foundries of the world. Maybe Micron may be interested, but Micron is doing it themselves. We'll see. And we'll take those wafers, we'll dice them up, and we'll put them in packages. And we're going to put our own packaged parts onto our own boards and put those boards through the EMS. So it's a expansion of the value chain now. It's very logical. We're going to be starting with a little bit lower end packages, probably on the high power photonics area for power electronics, for EVs, battery management systems, because we're a leader in manufacturing in automotive, by the way. All the top OEMs are our EMS customers. And we believe that we would like to get closer to our customers and understand their challenge, to bring their bill of material costs down also. So we're focusing on automotive and power electronics and QFN packages. And we have a roadmap for the next 4 years to expand to ball grid array, which are called BGAs. I don't want to get too technical, but a little bit less form factor without leads. And then the ultimate is getting into what's called chiplets and substrate-based designs. And those are literally cities inside of a chip where you're going vertically. You're stacking memories, you're putting chips on top of chips, and you're flipping chips inside of chips, and you're putting chips on substrates, and you're building little cities inside of the chip, literally. And that's a very interesting market for India, because you can have one chip from one fab, another chip from another fab, another chip from another fab, and put it all on a single package. You can have a 40 nanometer chip for automotive, you can have a 4 nanometer chip for vision, and you can have a gallium nitride chip for high voltage, all on the same chip. And these are getting smaller and smaller, and companies like Biswadeep's are working day and night on reducing the power. Today, your MacBook now is able to run for 20 hours, 23 hours. Your mobile phone now is charging in 5 minutes, and it's able to run for 20 hours. This is just the tip of the iceberg. So Kaynes is very clear that the compute, the infrastructure, the manufacturing we can confidently say will never catch up with the needs and the voracious appetite of AI. The world will always be doing catch up on AI. So the opportunity is space for young engineers. The opportunity is massive for young engineers coming into this industry.
Fantastic. I'm excited. If I could switch over to Semicon.
Please come, please come.
So,
we need all the help we can get.
So yeah. So as in, Biswadeep, can you tell me about the unique opportunities that are presented for companies around this, and what can companies do to capitalize on this trend?
Sure.
Kaynes, is obviously a market leader, and what are, other companies have to explore?
Sure. And Sarath always gives me the best lead possible to jump
you.
into. So again, let me touch upon the pre-silicon part of it. Right. We are seeing some very specific trends in the industry. See, the company I represent now, HCL Tech, has been in the semiconductor for more than 26 plus years, right? And we see specific change in trends. In the past, semiconductor development, and by development, I don't mean the manufacturing, the design part of it, was limited to one, the IDMs, integrated device manufacturers. These are the guys who would design their chips and also manufacture it, or the big fabless guys. What we are seeing now is there's a shift from these limited guys, and you know the names, right? I mean, we discuss the Intels of the world, TI, AMDs, to many players who want to build a unique one-off custom silicon for their system. And the technology Sharath mentioned, right, the chiplet is really helping, because I can pick up certain standard components off the shelf. I can build this unique secret sauce that I have, put everything on the single package, and take it to my system, right? So with that, two things are coming up. One, our opportunity is broadening. But at the same time, our offering also has to change as a design house. And this is not specific to
company, but also all the players in the ecosystem, they would now have to interact with companies who have not been in semiconductor, do not possibly desire to be in semiconductor in development, but want to build a semiconductor product. How do you address that? You basically broaden your offer to allow them to give you a specification, and you give them back a working parts. So it's not just good enough to say, okay, let me provide services on design verification. Let me provide services on design for testability. No, because they are not looking for that service. They're looking for the complete solution end to end. And this is where partnerships with companies like Kaynes will be really valuable, because you're taking a specification, you're giving back a working parts. That's one. Second, what we are seeing is all these companies, when they come, they do not really have the wherewithal to sustain a 3-year development cycle. If you go back years back, right, the big companies would have spent 6 months in architecture development, another maybe 1 year in design, then there's a tape out, then the chip comes back. Here, the cycle times are kind of squished. So, what we need to provide them, and what we are also doing, is we are providing them a kind of a platform offering. What does a platform offering mean? It's essentially like the way, you go to IKEA, you pick up certain components and build a modular kitchen. So there are 10 different shelf designs. You pick up a shelf. There are 5 different racks. You pick up something, and they integrate it in 14 days.
Okay.
Similarly, what we are saying is most of the components on a system on chip are standard. You have different flavors of DDR, dual data rate memory. Pick up something. You have very standard microcontroller cores. Pick up something. And then you have this intellectual property of yours, which is secret sauce. So what we are now offering to our customers is, here, this is the platform. Rest of the stuff is standard, pre-verified and integrated by us. As long as your IP, intellectual property, has a standard interface to the rest of the world, think of it like you've designed your own nice custom bedroom, which has the door standard. That's all. It can snugly fit into the platform. So that's the second offering that we're giving. So broadening the market, providing an platform base. And the third one, as Sarath mentioned, right, we are looking into this whole 2.5D, 3D integration of package, where we realize silicon real estate, right, the real estate of Bangalore is really expensive. So you grow up, you build multi-story. These are the 3 main trends, I would say, that is coming to us as an industry.
Awesome. Great. So now I want to kind of open this stage to discussions around talent. Okay. So I would like first to start off with you, Biswadeep. So there is this constant scare that the number of jobs are going to reduce, and there is constant things that say there is only talk about AI, and electronics is forgotten. I don't know how AI will survive without semiconductors. So I want you to talk about what will happen to the jobs as per your perspective. Will new ones emerge? Will old ones die? Or will old ones remain and new ones come? What would happen?
Okay. So I'll start with a bit of history. Okay. I think folks here, all of us, remember the days of banking automation. When banking automation first came to India, the biggest fear was, wow, with this automation, all the jobs of bankers are gone. But they still have a lot of bankers. It's just their services they used to provide have changed. Things that they used to do on the ledger book and pen and paper has been replaced by computers, and they are providing a different level of services, much more value added. I believe same thing will happen within semiconductor industry too. The job profile will start changing. It's not the numbers will reduce. In fact, the numbers will increase. But the jobs profiles will start changing from doing something very repetitive to spending more time in analyzing, debugging, looking at various options and picking your best architecture.
which gives you best power performance area. Now, to be able to enable that, I think we would, and this is my personal opinion, we need to focus. I believe we have now, in an attempt to make our engineers more employable, more readily deployable, we have started focusing a lot more on skill, right? But chances are some of these skills will not be required because machine will take over. So we again need to go back to knowledge. Spend a lot more time on fundamental knowledge. I'm not saying that skills are not needed, but the emphasis on knowledge should not go down in favor of skills. There, what happens is once you are equipped, as Professor mentioned, right, with the fundamentals of digital electronics, with the fundamentals of computer architecture, with the fundamentals of algorithm and automation, not necessarily saying I know Python. Python is the end thing today, but 5 years down the line, maybe it will go off. But understanding algorithm, understanding electronics. So while from our side in industry, I know we are pushing for better industry academia tie-ups. When we go to in academia, we keep on saying your students need to be industry ready. I think we also need to sit back and say, okay, not at the expense of fundamental sciences, the mathematics, the physics, the electronics that goes in. Today, I sometimes worry when I see students have forgotten doing first derivative using first principles.
Mhm.
The old that formula fx plus h minus fx by h limit h tends to 0 is possibly not taught. But you still need to learn that. And that's something that I want to convey when I meet students, when I meet teachers also, right? And yes, I definitely, it's my vested interest to see you guys have more and more understanding of the tools that we use and flows and things like that. But do not forget the fundamentals.
Got it. Got it. So that is very actually, informative and insightful. So I want to, add Sharat's perspective to that. So, Kaynes is 3,500 and, expected to hire around 800 to 900 folks in the next 1 year. So, Sharat, what kind of people do you look for? First of all, do you have challenge in finding people in semiconductor? And if you have, what kind of people are you looking for that you're not finding laterally? And in terms, I'll come to the second part of the question next.
Keynes isn't alone on talent requirements. The whole globe has a dramatic shortage, and that dramatic gap is going to get bigger, not
Mhm.
smaller. The job ranges can range from semi-skilled, 10 standard pass out with an ITI degree to 12 standard pass out with a diploma. We're working with BTechs, MTechs, PhDs. We are looking across the board for machine tool operators, which have diploma and skills. You need to analyze that data. You need to do statistical data analysis. We have to improve the yields in everything we do in manufacturing. Once you get into manufacturing, in addition to the basic fundamentals of electronic circuit theory, algorithms, we need to start getting into the chemicals and also the mechanicals. So now you're starting to talk about mechanical and mechatronics. You're starting to talk about the raw materials that are needed for the plastics and the epoxies. You're looking at skills in thermodynamics for the heat dissipation, how to control heat, how to control losses. So it's going to be expanding across electrical engineering, computer sciences, mechanical, and also chemical, just to put things in perspective. The current outlook, we're currently in India around 1.3 lakh design engineers today. I'm not sure about the manufacturing number. The latest reports have said that we need to add at least another 85,000 to 1 lakh chip designers, just design. That's going to have an exponential effect on the manufacturing. One chip that Biswadeep tapes out with a team of, say, 100 or 200 people will be going into 1 million devices, right? So to make those 1 million devices running 3 shifts in multiple factories will require talent. And America is building these fabs and this ecosystem because of the current geopolitical scenario and their aging populations in Europe and in the United States and in Asia. India is the youngest demographic dividend. The globe has no choice but to come to India as the largest democracy for this talent. So we don't only need it just for Kaynes. Kaynes is also looking to serve global markets as well and in these areas and to take a leadership role. So for NCGs, I wanted to talk a little bit about the challenges that the industry faces. In the case of, uh, let's take a new greenfield industry like OSAT that we're doing, we'll take interns, we'll take NCGs because it's very niche, right? There aren't that many. But in the case of chip design, the large GCCs, they need laterals more than they need the NCGs, and they count on the design services ecosystem to train them after college and have these finishing school concepts. Foundry and manufacturing is a little bit different. The GCCs, like we're talking about AMD, NVIDIA, Qualcomm, the product companies like Broadcom, etc., they pay very good packages for 3+ years laterals, but really getting that 0 to 3 is the biggest challenge in this industry, in my humble opinion. It's always a relationship that then comes in. Will you take a fresher? Will you take 1 year? Will you give us a buffer resource for free? Will you allow us to take out bad ones and put in good ones? The big companies don't want to deal with it, so they're giving it to the design services company, which in itself is a huge market because we're producing about 5 lakh engineers a year, of which only 5,000 are employable. So the opportunity to make them employable, not just educated, but employable, is also a massive task. Soft skills, interview challenges, how do you dress, how do you approach an interview, how do you get to complex problems, lateral thinking, design thinking. So the point I'm trying to make is on the manufacturing side, it's starting to emerge, and we can't get enough talent. And if they're skilled, if they're not going to computer science, which is a big challenge, they're staying in semiconductors, and then not only are they aware of a semiconductor, but they've gone through the coursework and know the fundamentals. Then the task is to get them onto packaging. So we have our work cut out for us because we are so far away from what the knowledge is of these. So awareness, 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 roadshows, hackathons, webinars, seminars, podcasts like this, spreading the word. What is a semiconductor? What is the future jobs? Is going to be first critical before getting into where we want to be on the packaging.
Got it. Now coming to the second part of the question, Sharat. So as in you see that there is a so what happens is, especially the services firm prepare the talent for the GCCs to kind of poach it from, and then that has been the norm with most of the services companies that you see. So they create a post college this thing. So I wanted to understand. So if instead of getting them on payroll and then training them for 6 months and writing off their salary and training as a cost, is there a way that you think you can better equip these freshers, like what we were talking about, center of excellences, 1 year internship, and then how do you think, what is your perspective on what would you, if I give you a magic wand, what would you want?
We need to bridge that 0 to 3 gaps. That 3 needs to come down to 1 instead of 3 years because that gap is still large. And that it's an ocean for these freshers and they're lost. They'll take anything. Now, to bring that 3 down to 1, they have to be industry ready and hit the ground running. So you need to go and double click on the fundamentals on the specific protocols. And you need to start zeroing in and getting serious on where in the design flow or where in manufacturing you want to be. It's not enough to say, I want to be in chip design. We need to get to that next level and say, I want to be a chip designer in digital verification doing PCI Express Gen 3. You understand?
Mm-hmm.
You have a high likelihood of getting picked up by a GCC directly without going through a training school.
Got it.
Now, the training institutes are also partnering more and more with the GCCs to put custom built curriculum and custom built programs together, whether they're short term or midterm. Those are highly effective. Basically, the GCC will give a spec to a college or a spec to a design services company, and you would train the trainers to then be able to deliver product company X's specific requirements. That works. That bridges the 0 to 3 gap a little bit. Then on the the 0 to 3 gaps is probably the point I wanted to make. The second part of your question on the challenges was?
As in, how do you make this, this reduce this 0 to 3 to less than 1 year, one, and then, how do you think academia and industry can collaborate in form
Hmm.
of internships
Yeah.
and COEs?
So now again, front end design, back end design, front end manufacturing, back end manufacturing. The next logical step beyond theory would be hands on approaches. So in front end design and in back end design, there's a whole vast field of emulation, pre silicon validation, architectural analysis, software simulation, etc. Those require labs. So I think hands-on labs, in addition to the theory, are going to be important. On back-end manufacturing, actually doing tape outs, MPWs. I'm not talking about doing a production chip. I'm saying get that student to tape out their own chip along with many, many other students on a single die. So that is something which would be very attractive to anyone who's hiring. I've done a tape out. I have done a complete test bench for a USB protocol. It's an example. On manufacturing, the same thing. We're planning to set up COEs at Kaynes, where we're actually setting up small prototype lines. So in parallel to the theory, we want to do hands-on labs and actually take them onto the equipment and actually experience it with the equipment. Kaynes will absorb these ourselves, and they will be much industry ready than they would be without having those hands-on and theory only. So the combination of the COEs, labs, along with fun projects like hackathons, ideathons, etc., are all going to be needed. And industry appreciates the winners of those hackathons. They appreciate the fact that an industry with an academia has brought 1,000 students filtered down to 10. That's a big deal for a large company, because then they've said that we've been able to get the needle in the haystack, the diamond out of that, where we're reaching. And I think another aspect is the tier ones are taking a leadership role. The IITs, we've expanded the number of IITs, we've expanded the number of triple ITs. They're taking leadership roles. They're welcome to host the tier 2 colleges and even the tier 3 colleges and even the government colleges. I see a lot more handshaking and a lot more cooperation, not only within the states, but even across the states. And I see that the leadership and the ministry is working very well with the top tier ones to expand it down to the tier 2s at the base of the pyramid.
Got it.
Because that's where those gems are, which are unable to be unearthed.
Got it.
And that's happening today. And they should bubble up. So that's how it'll all come together. And Sir gave such great examples of how NVIDIA is setting up COEs. I'm sure they'll be giving you little Jetson packages, little GPUs.
Yes.
Alpha Wave will probably be talking about 2.5D and 3D packaging. They're talking about cutting edge IP. In the universities, we start with base protocols, but they eventually mature into the advanced technologies. For example, in colleges, we do 8051. That's nothing but the foundation of x86 and RISC. We do SPI. That's nothing but basically the foundation for parallel computing. The I2C is nothing but a serial interface, which leads to USB. So the fundamentals then need to be built on into the actual industry required protocols. And if we can start getting expertise on IP protocols, they're here to stay. We need to get on the MIPI standards. We need to get on the industry standards, the industry bodies, the certification bodies, and that needs to come from the academia also, I think. These are a few areas where I think we can address.
Fantastic. So, Shripad, coming back to you, right? Out of what Biswadeep and Sharat have told, what are the things that are already things that you're doing at Vishwakarma, and what are the things that you think give you an insight, and what you think can be done to give students a better opportunity, probably make them more employable, and then get more of them onto E&TC than going to regular IT jobs.
Right. Yes. So as Sharat mentioned, the requirement of industry, and then the like 5 lakh engineers getting pass like every year, and of them around 5,000 are like what employable. So that is the biggest challenge, and we understood this. And to mitigate this challenge, we started working closely with industry. And one of the option we started, the COE was one of the options, Center of Excellence. And then some companies are ready to help the academia. So with the help of those companies, we did it already. um, Basically, like what we understood, one very important thing here. Now if we see like what universities or academic institutes in United States, or say Japan, or Western Europe, so there the industries are very closely working with universities. And because of that, a very like what skilled talent pool is ready there in the universities. Researchers are there, and even the university labs are like what state of art facilities are there in the university labs. And if we analyze like how they reach that stage, so the answer is industry. So industry is very generous to these universities. So initially in those universities and those countries, industries started like offloading the work which was not time bound. So that kind of work they started giving to universities, and universities took time to understand the requirement of industry and to match their like what requirement. And then gradually they develop that talent pool and that abilities. So such things should happen with the Indian academia. So industry is coming up with very good initiatives. So academia is also shaking hand with industry, but such more and more interactions should happen. Now, as I mentioned, NVIDIA come up with a training program. NVIDIA come up with problem statement. NVIDIA come up with hand holding. So they have not just like given something and just forgot, right? So they deployed, and they like what help us. They're almost like what 40 plus professionals from NVIDIA. They were hand holding faculty members of VIT Pune, and then the students of VIT Pune. So that was really like what amazing part. And because of that, the faculty members, and then the lab infrastructure, and then the student, we could develop good talent pool. And as I mentioned, because of that, the complete semiconductor industry and then the ecosystem got benefited. So such interactions should happen more and more. Such talent pool need to be created with the help of industry. That I feel.
True
Right,
that.
right.
Kind of summing up all the three
Mhm.
of you, right? So what you're saying is more industry, non-time bound projects
Right, right.
could be a learning ground for these folks, and then setting up labs, providing state of the art, facilities and products for students to access would be another one. And COE specific.
I'll caution you with just one thing is just don't stop at setting up labs. I think what Professor also mentioned is industry needs to have a skin in the game for in a continued basis.
Got it.
Just setting up a lab or just giving a grant and then claiming, oh, I have done this great thing of giving $1 million to an, that doesn't help.
Real true.
You have to be there. You have to be part of that because the students are learning from you on a regular basis.
Got it.
Right. So that has to be the approach.
Got it.
Yes, it's a long term problem, as you mentioned, right? No, something which is not critical, something that is not going to impact my revenues in the next 6 months. More blue sky research, but be part of that journey. Do a regular review, then it helps.
Right, as Vishwadeep mentioned, it happened, and it is happening actually, and it happened at VIT. Like what happened when we started some programs with NVIDIA and then other semiconductor companies. Then what happened? The companies started. They came to know about our master's program and then our doctoral program. So some of them uh, joined our doctoral programs, master's programs, right? And because of that, what happened? We could get that expertise at VIT. This helped a lot. And then eventually what happened, few of them joined academia also. So now in VLSI domain, let us say 100 teachers are there, so 60% of them are from industry. So we have faculty members from NXP Semiconductors, Cadence, Seagate, even Alphabet. So this helped a lot.
In fact, now you have the concept of a professor of practice. You do not have to be someone from the academia. If you have, I think, 20 plus years of industry experience, you can be a professor of practice. So
Yes.
essentially, you're not teaching possibly the theoretical subjects, but you're sharing your journey, your experience in more application oriented domain.
Right, right.
Got it. And I see it from the industry perspective as well. I believe Sharat would agree. The cost that a corporate or an industry is putting into these labs or these centers of excellence, right? One solves the problem of not finding people. Two solves the problem that you get ready-made talent, and your training cost comes down. So and also, what happens is, it's like every year you have a predicted number of intake from a certain college or a certain this thing. And also, what, one more thing that, if budgetary challenges are there for smaller colleges or smaller companies, they can kind of combine two three academic institutions, where one or two of companies, industries kind of bring it together, and then they do it. And more importantly, like you said, Biswadeep, it's not about setting it or putting in the money. It's about a regular collaboration. I think, from a talent perspective, you would agree that that is a worthwhile investment that kind of gives you assured returns than giving an offer, waiting for 60 days, and then the guy not turning up and joining you. So I believe that would be a part, right, Sharat?
Yeah, absolutely. I mean, of course, there's a capex investment in setting up these labs, but what's the use of having a manufacturing facility if you don't have people to run the machines? That's a bigger problem to have, right? The money is there. The money is not the issue. The government has been very generous with the C2S program, with the EDA tools. The EDA tool also the CTS also involves development boards as well. So there's also very good support, and Biswadeep nailed it. The last thing you want to do is just do a photo op, say you've done a ribbon cutting, and then that thing just lies and catches dust. That's a tragedy. This hand holding, which you mentioned, is very critical. The fact that NVIDIA has put in skin in the game and people. And then not only that, we didn't touch upon the subject of the internships, right? Now you have a closed loop system, and you have a process which is repetitive now. And you try it, and then they take the cream of the crop into NVIDIA on their payrolls. Again, you would have bridged that 3-year gap now because they have such a tight collaboration with VIT. Plus, you have the hands on experiment, plus, you have the involvement of NVIDIA. They'll take out of those 180 students, they'll take 10 to 15 of them and give them fantastic packages.
It is happening already.
It's already
Yeah,
happening.
Right.
it is happening. So, as in, continuation to what you said, what are the special government initiatives or programs do you think are already benefiting the industry? And what do you think more the government or the academia can do to, further make industry's job easier?
Okay. So again, we'll break this down into segments, and I'll first start at a high level by talking about the names of the programs, and then try to go just touch the surface on the impact they're making. So at the academia level, the C2S program. The C2S program is nothing but a rebranded name for the SMDP program, which is a Special Manpower Development Program, which started back in the early 2000s with Kaynes and Synopsys pioneering giving the EDA tools in the universities. What they found was is the EDA tools were given, but they weren't used. They didn't know how to use them, and then they weren't able to get the tape outs like we had envisioned early days. And then it migrated to 2 and 3 to C2S today, which is EDA tools plus the development boards. For academia purposes only, not for commercial. The universities which have the C2S license are now becoming nodal universities, which can now give access to EDA tools to other universities as well. It's hand in hand with CDAC also. CDAC is a Center of Design for Advanced Computing, and we have multiple CDACs across the country. So they're doing a hub and spoke method and a mesh network, which is good for the tools. So accessibility, just like internet, needs to be made available. This is C2S. And like he mentioned, the very expensive EDA tools are now available for academia and for students. And now they are able to envision that I can actually create a product on my own. Now, once they've graduated and they have a startup, an IoT startup or a power electronics startup or an EV startup, they need the EDA tools again because at the school they've been doing only research level, right? Now they want to make a product. This is the DLI scheme, the Design Linked Incentive Scheme. Again, they give you the EDA tools, they're setting up plug-and-play facilities, they're giving you access to development kits, you have a subsidy for the development kits and the hardware for the subsystems, and you're able to get your product to market and have a POC. Once you have the POC, now you want to go into mass production. Today, the startups are not in mass production. There's a few cases, maybe Boat or Micromax, or some examples are there. But then you have the PLI scheme, which is a product linked incentive. And that's where all the big boys and the cell phone industry, the laptop industry, the data server markets are all jumping on the PLI scheme, which is, again, for every product you produce, you can get 4 to 6% of top line revenue back as an incentive linked to your production, and plus 50% subsidy from the center. That policy has been rippled on down to the states, and the states are topping it up with another 25 to 30%. So now you have a situation where the capex, your development cost of setting up a startup, is funded to the extent of 75 to 80%.
Mhm.
And your EDA tools are now given to you as part of the package, which is basically your biggest chunk of expense. So that's going to be propelling the designs to do. And then the big guys are doing the PLI scheme now. As you can see, we're number 2 in mobile phone. And now what you're also seeing is the domestic content and the downstream Make in India vision that's starting to happen. And you're seeing the tie-ups with the globals and the local India. HCL has announced a massive tie-up with Foxconn. VVDN is tying up with HP. And you're going to see more and more of those happening because of the PLI scheme.
Mhm.
Highly successful. Then you have an EMC scheme, EMC 2.0 actually. We're on the second version, which is nothing but electronics manufacturing clusters. And so the states have signed up for these EMCs and they're allocating parks, 1,000-acre, 5,000-acre parks with plug and play facilities so people can come and start setting up their manufacturing on the go, power, water, roads, being able to set up your lab equipment, UPSs, etc. This has been taking off. So now you're seeing electronics parks and manufacturing clusters come up across the country. They're also being smart about focusing on clusters which are applicable to particular industry domains. So you have automotive clusters in Pimpri and Pune. You have Haryana automotive clusters. You have AI clusters in Hyderabad and in Pune also. So example, those manufacturing setups which are specific to industries are being set up under the EMC scheme with the states. So then you have the spec scheme, which is the last one, and that's nothing but downstream support for downstream electronic components. Of course, we're talking about systems, and today we're importing all the chips from Infineon, from ST, from NXP. Those are the microcontrollers and the SoCs. But there's also passive components and discretes. There's also even hardware components like connectors. Those are all imported, everything, 100%. So now they're giving incentive for startup engineers to actually do it at the component level.
Mhm.
So now if you have the components, you have the microcontroller, you have the board, you have the EDA software, you have your startup impetus and pushes. And of course, I don't need to talk about every state is doing their startup acceleration, their elevates, their, Gujarat, all the states have their electronics policies and their accelerations, which is also enabling and helping this. And then the big guys are now availing, and we're becoming a leader in contract manufacturing, but we're still importing. But now we're starting to move shift left, shift left, shift left, shift left.
Mhm.
So that's how it's going to emerge.
Got it. Got it. That's great. And any specific programs or any more initiatives probably from the academia side that you think should happen?
I talked about it. I think the biggest challenge is at 0 to 3. If we can get these freshers employed immediately rather than having to wait, you're going to see a flood of employment. You'll see a flood of employment. The GCCs are very picky. It's very painful to pick up untrained and new college grads. And it's a chicken and egg situation where the large companies, before they hire the NCGs, they don't want to take the ownership of parenting them and babying them. They don't have the time. It's ruthless, the time to market windows. They cannot afford for the, I'm sorry to say, the weak don't survive, right? No, not everyone can be brought along. So it's important that these guys are ready and hit the ground running, and that the industry is ready to absorb them. So we talked about some of the strategies that can be used, but if we can bridge that, I think it'll open floodgates. And then if we need the senior people, like I mentioned, it's a chicken and egg. The large companies will hire the freshers provided the company that's offering the services gives them a lead to manage them. They don't want to parent them. They want you to bring in the parent and you to manage it. And they want a single point of contact. and they want to be able to give that lead, that 10-year guy, a project and say, you do it with your 3 years guys, your juniors, I don't care. And you're seeing an advent. Once you're able to reach that level of maturity, the concept of offshore development centers is, it's nothing new. We're already doing it in IT, and an offshore development center is nothing but a physical space which is protected with the VPN firewall, with network security, biometrics, cameras, etc., which ensures that the intellectual property is maintained, is safe, that the design files are protected. In that situation, when you've reached that level of maturity, and HCL is doing it, and the large companies are doing it, they give you the flexibility to bring in freshers on your own, and you take your own risk.
Got it.
If it's not working out, they have the option to pick and choose. And like you said, NVIDIA takes the cream of the crop. So they come in. So now you have an infrastructure. You can bring in the NCGs, but you have to have the necessary leadership. And then that's kind of the point that they don't want to get really involved in.
Cluster model.
A cluster model. They call them pyramids. You set up these pyramids. Then you keep on building it, and those they become 1 year experience, 2 year experience, and then they're 3. Then they can move within, and then if you have that critical mass, then you set up your own training center. And if you can build that whole ecosystem, then you have a viable business model, and it becomes a win-win-win.
Got it. True that. So, Biswadeep, coming to you, right? What is your perspective on driving growth in emerging markets like India? What should India do to get to where Taiwan is in semiconductors?
See, I have two thoughts to it based on what I've seen, right? I mean, when I started personally, there was a major focus on this whole phrase called low cost. We we marketed cost arbitrage of India in a big way. Then somewhere I think around 2009-10 we realized cost arbitrage is not going to be sustainable. Because for every low cost geography you have, there is going to be another lower cost geography. You cannot keep on saying that, okay, I am low cost, hence give me work. So it got replaced by value arbitrage. You start going and saying, give me work because I bring in this value. That was the first big change happen. And I think that needs to continue. Second one that we saw, and I think that Sharat has mentioned it really well, is during the COVID, we realized that unless you have a stable and sustainable supply chain, you cannot thrive as an economy. You cannot just be focusing on one aspect of it, which we were. For a very long time, we were just a design powerhouse of the world. Now, what we are looking at is the entire product, from the specification to the complete design to manufacturing, testing, and bringing it up. And these are areas where now the startups, aided by all the incentives that Sharat mentioned, right, they are focusing. I see that as a big change, and that change needs to be positively influenced to grow further. We cannot and should not go back to the environment where we are called, oh, Intel is the services capital of the world. The big behemoths of services who were and are in India, yes, they thrive. But there is to be an equal focus on a product ecosystem. And that, I think, will not just benefit that company which is building the product. It will benefit folks who are designing. It will benefit folks who are doing the manufacturing, testing, the entire distribution chain. And as Sarat mentioned, if you get into manufacturing, you essentially, it's not one company. In Taiwan, we talk about one TSMC, but it's not one. You think of the number of components that gets into a fab, chemicals, the equipment, even clean water, right? So it actually will give growth through large number of companies in mechanical sector, in electrical, in even civil. You'll see specialized civil structures coming up, because when you're building a fab, it has to be resilient to certain, say, tectonic effects and things like that. So there's no end to it.
Good part is we are on that journey. But the necessary part is it has to be continuously fueled, because this is the stage where we are in an incubation mode. If we stop at any point providing the support that we need at this stage, it cannot be sustained. Give it another decade or so, it will be on a self sustaining mode. But today it needs that support.
For Sharat and Bishwadeep, I have one question for you. As you mentioned, we also realized during COVID time, just we wanted to just for our project, we need one GPU based machine. And that time we ordered that GPU based machine and it took almost 8 months
Yeah.
to get delivery. So as you mentioned, supply chain, like what another that
Resilience.
system resilient, right? So basically, like is it due to like what heavy reliance on import, like right now how much import we do in this domain, and how long will it take to like what get the overall like what supply chain management, or otherwise you can say the independence in semiconductor ecosystem.
We're importing 100% of our semiconductors today.
100%.
100%.
Even passives, as Sarath mentioned,
Everything
the
is imported, sir.
resistors, the precision capacitors that are needed are still imported.
The fab we have in SCL is a low volume. I think 2,000 wafers a month. They're supplying chips for our Department of Defense, for our satellite programs. Good technologies, older geometry, very stable. But that's it. Everything's imported.
No, if
And it's a
100% is import, then how the internal systems will blossom then? Like what will happen and how long will it take then?
so as I mentioned, we have EMS today, and they're coming as kits. Those kits have imported semiconductors and passive components and all imported. So that's the first step, is to start doing those. And that means you have to build the bare PCB like we talked about. We don't have the fab, the front end manufacturing, but we can, of course, do the back end manufacturing, which, by the way, has been dominated by Southeast Asia and Taiwan, Korea, Malaysia, Vietnam, and these geographies are dominating that. Philippines. India's a little on catch up mode. Just you have to think logically, right? The fab is the end all and be all, the $10 billion investment. 1/10 of that is the PCB and the packaging. 1/10 of that is EMS. So it's economies of scale, and it's also exponential in terms of out throughput. Simple thing, like he said, tectonics. But there's another huge factor which all of it requires: a clean room.
Yeah.
So before you even start doing a package, before you start doing a PCB, before you start doing a fab, start building the clean room so you can have something to put these inside. And that itself is a huge industry. So step by step, I think the Tata Fab 28 nanometers will be a very big deal for India. It'll be monumental. It'll be a game changer. It'll be pivotal. And it's going to be a renaissance period for India once we're able to get a 28 nanometer fab in Indian border. Up till that time, we're just getting to that point, because this will take around three to 4 years, if not more. The upgradation of SCL will also take about 3-4 years, because again, this equipment takes long time to build. The answer to your question about the GPU taking 8 months is nothing. First of all, they're ghastly expensive. One NVIDIA GPU is like $60,000, the high-end ones. And they're not available. TSMC can't make enough of them because NVIDIA has Oracle, Tesla, Amazon, Meta as customers. Where are we going to get those
specific period there was panic
Right, panic,
purchase.
right,
panic
Every-
purchases? Where are we going to get those?
Right.
Right. So the point is, either we wait for it and pay those astronomical rates and have to import it, or we have to do it ourselves. So now you're seeing people starting to design GPUs. Let's see.
Sarad mentioned a very interesting phrase, Renaissance of India. So if we actually look at the actual Renaissance that happened in Italy, the reason it bloomed, the reason we had the Da Vinci's and the Titians at that time was trade had bloomed in Italy. Bloom of trade led to available funds, funds that could be channelized towards culture, art, and everything. Take a similar thing, right? Gradually, from a point where we had low foreign reserve to today, India has reached a stage in economy where they are being called a powerhouse. Now they're taking that excess money, excess in relative terms, of course, but excess, and deploying in areas where we were scared to invest in. Why did we start servicing? As I said, right? Because low investment. What do you need? You need 10 engineers. You need to ensure that the cash flow for these 10 engineers, maybe for a quarter or 4 months, is maintained in your bank, and their laptops. You're off to business. But if it's a fab, or if it's even an ATMP, you need massive investment and an appetite to stay invested for a very long time without expecting return. For that, you need to have a stable economy. So I think this is a perfect launchpad that the country has reached, from where we can start aspiring and dreaming of this.
True. Very. Actually, we are at the right cusp, at the right leadership, so and the right policy making. All of this together will propel it to the next stage. And kind of finishing it off, right? Want to ask you, Shripad. So I want to specifically, to outline, what was the benefit. So, as in from academia perspective, I want an answer. What was the benefit that NVIDIA got by setting up a COE? How much did they shorten their training period? Is there any cost figures that they saved up on? And because of that COE, how many other students who did not get into NVIDIA got into similar other companies? And what was the benefit, indirect benefit that the students got?
Right. NVIDIA didn't set up COE. Actually, that was a like what program with NVIDIA. Aeron Systems set up COE. So the benefit of COE actually, if you see, um, so as I mentioned, now like coming to that COE part. So Aeron set up COE, and Aeron provided training to our students, faculty. So as Shrath mentioned, it worked on two levels: train the trainer and train the students, basically. So because of that, what happened? Um, so teacher could understand the requirements of industry. Our lab infrastructure was developed with the help of these industries. With Aeron Systems supported for some lab infrastructure, some softwares and some hardware boards, and then NVIDIA supported with trainings. As I mentioned, 100 hours of training they conducted for our students and teachers. And because of that, what happened? Aeron gave us hardware. That was most of the hardware was of NVIDIA only. So Aeron gave the hardware. Aeron set up the lab infrastructure, and NVIDIA taught us how to use it. And because of that, what happened? The understanding of teacher got improved, understanding of our student got improved, the quality of our projects improved, and that reflected in their employability skills. And because of that, as Sharath mentioned, so many companies got cream of the crop, and we could develop talent pool to meet the requirements of semiconductor industry. So these are the benefits actually. So the training and then the handholding by companies like Nvidia, and then John Deere is also one of the examples. So what John Deere did actually, so John Deere realized that okay, they need certain skill set in students, so they started offering elective in semester 7 and semester 8. And then because of they conducted elective for like the complete batch, the complete class of, let us say, 60 students, and they could recruit maximum 10 to 12 students. But now remaining 48 students, they are now exposed to that skills, and they got exposure on that skills, and because of that their employability got improved, and other companies they got placement, they got internship in other companies. So this way, when industry coming to campus and shaking hand with academia, so there are massive benefits, and we are one of the, like what you can say, the case study for that, beneficiaries for that. And we illustrated this model to academia in our region, and they also started developing, they started utilizing such handshakes, and the impact is evident now. Now, Government College of Engineering, Pune, there are some other engineering colleges in Pune. They started utilizing this model, and the entire academia is getting benefited. So, as Sharat mentioned, 5 lakh passing out and 5,000 employable. So that employability is getting improved. So that is that advantage we can see.
Got it. How would this benefit the industry, Sharat? How would it solve your problem? The final question.
We have to get these chips out the door on time and perfect. And we need people operating these machines. We need to go from single shift to double shift to 3 shifts. We need to build more facilities. We need more clean rooms, and that's all going to need the talent. The appetite of the industry is voracious. We'll never be I shouldn't say never, but we're always going to be in catch up. Talent is and will be the single biggest challenge that our industry will face for the next coming decades.
Got it.
It's going to be number one challenge. It's not just us, it's everybody. And thank God that we're in India. America and Europe are going to have a much bigger challenge. And that's why they're being so nice to us, because they are going to count on it. And we shouldn't get in a situation where we lose it to the US and Europe and then they leave India. That should be avoided.
I think that is, from a perspective difference from, a couple of decades back when some of you started working, the brain drain, now there is a reverse brain drain because India is also paying well,
Hope
and
so.
India is also having a lot of opportunities. And more importantly, it's not lucrative anymore to go outside of India. You unless you want to clean your own vessels and you want to sweep your own floor, it is
Exactly.
not lucrative to go out of India anymore, to be very honest.
Exactly.
So that's the point. So it was a great informative session with all of you here, and then more to semiconductors as I am learning through in this process of what is the impact of semiconductor industry in the whole global dynamic. If artificial intelligence and data science have to survive, this has to bloom, and bloom very fast.
I'd like to leave one thought. Just came up tying things. See, today industries have been mandated to have a CSR budget, right? That's specific. If your revenue threshold is this is your percentage. Maybe there has to be some policy saying if your number of engineering power crosses a certain number, you need to partner and handhold so many number of colleges or universities as a policy, right? That way, what Sir mentioned, that 0 to 3 year gap is going to come down, not just for two companies setting up a COE in one university, but as a process.
Got
And
it.
I'll tell you what, it's not that I have a shortage of roles in my organization. Because of this ability to, I mean, my expectation for the NCGs, new college grads, to hit the ground running, I'm shying away from freshers. So it's not that lack of opportunity, it's there. I can grow, I can absorb. But what am I going and telling my talent acquisition team? I'm telling, no, nothing short of 3 years, preferably 5 years. I shall stop saying that. So maybe in that kind of a policy where there is more active policy to kind of partner between industry and academia, a policy guidance, it will help bridge the gap.
uh, Actually, companies without even a policy company, it's a strategy for them to reduce the recruitment costs or to get more employable people if they deploy the CSR funds on colleges in setting up, because it's also a possibility. So you deploy, so instead of a common social measure, you should still do that. But then when you do this is a larger good for the society.
Yeah, I don't want to take off the CSR part of it, which is really helping a different strata of the society. But I'm sure there are R&D budgets and
A small chunk of it.
small chunk. Yeah.
Not the entire budget. We want the companies to do good for the society at large, but then making people employable is a bigger good to society than to give people free food. You're
Yeah.
teaching people to fish. So that, I believe, is a much bigger responsibility of corporates than to just hand out free food.
Yeah.
Free lunch will not last forever, right?
Exactly. In fact, I've seen this work in one specific company I worked for, right? Where
when you were on the threshold of getting a technical ladder nomination, out of the 100% of weightage, it's a nomination. You can never be promoted. You'll be nominated by your peer group. 20% of that was role modeling and mentoring. And you had to write something that you have done for the academia, for the academic ecosystem. Okay. So it's not that you come and say, I am a fantastic engineer, I've done so and so things. Of course you have done. Of course you have filed patents. Of course you have written papers. But how have you role modeled and mentored? I think that if you broaden that, broad base that, will incentivize professionals, also folks who have completed 10, 15 years in the industry, to reach out to academia and help bridge that gap.
Vishwadeep, you mentioned that the opportunities are there. Now, just as an example, basically, we have realized many companies are doing that. As you said, in your company, your organization, opportunities are there, but still you uh, convey to your tell to your talent acquisition team that no freshers, you don't want freshers, and minimum 3 years 4 years experience guys you want, basically. And this is happening with other semiconductor industries as well. Actually, we realize that. So basically, what exactly you look into those, what kind of skills you want? So, what kind of skills you see in a guy with 2 year, 3 year, 4 year experience, and what you don't get in fresher, basically. So we,
I'll tell you, I'll give you a domain agnostic
right,
answer here.
right.
See, because I mean, if I go specific domain, I'll say, okay, I need this language or this tool. No, let's leave that aside. And things like, and I think again, Sharat mentioned this. One is some of the softer aspects, as in simple things like how do you communicate, how do you write proper emails, how do you interface with your customers. Customer can be anything. It's not that you're like a spokesperson of the corporate,
Correct,
but
right.
how do you kind of properly present your
So
is
soft
one.
skills. You
Soft
mean to
skills
say
is
soft
one.
skills? Okay.
Second, again, this is domain agnostic. How do you debug? How do you explore? Today, I find it difficult often to explain to my engineers that running a step is not enough. You need to open that report file, see what's really happening under the hood. If something is not working, the easiest thing, and again, I keep this to saying it's in jest, but it's really happening, is the first thing my engineers do is send an email. So and so step has either crashed, failed, given error. It's like, when you are playing soccer, you pass the ball. I have passed the ball. It's no longer my accountability. You are still accountable. So please pause, open the report files. Okay, first time, maybe out of 10 cases, 9 times you will not be able to figure out, you'll still send that email. But that 9 will become 8, 8 will become 5 very soon. So that interest in analyzing, root causing, debugging. This is one part. Interest in learning more is a second part, and soft skills. Tools and all that are domain specific. That I don't want to get into.
Right. Thank you for this insight.
So actually, they're right. Shripad, kind of summarizing, right? People pay bigger packages to better colleges because at a high level, college is a filtration mechanism. The moment freshers are out of college, right, everybody becomes a fresher. I don't know who's who. The amount of effort involved in a company, this is not specific to semiconductor, this is like, I heard it in previous part, it's water everywhere in the sea but no water to drink. So you kind of see a lot of talent but none of the talent is usable, and then it's very cumbersome to hire somebody who has got out of college without a job. Is technically, 1 in 100 would be that gemstone. For to get that 1 in 100, I'll have to pass through 99 people, 99 steps of misery for me to do it. And the stickiness of the fresher is also very very a big problem. They come in, they leave in 3 months, 2 months, suddenly they disappear. All of this is not something a bigger company would want to handle at all. That is where, like this 1 year internship, 1 year he's kind of, glued to you. Then that helps. So in terms of college, right, whatever students who get jobs when they are still studying are the students who will get jobs. Once they are out of it, even if they are an IIT graduate, somebody will be like, why did an IIT graduate not get a job in college? What is wrong with him? I don't want to try my hands with him. I would much rather prefer somebody who is a, tried and tested person. So that is the, general approach to company. So there is not a problem that you can solve. The objective of a college, according to me is, I am an anti-establishment person, to be very honest. I don't believe in, this skilling, upskilling, reskilling, cross-skilling and all of that, because none of that is going to help. As long as your base fundamentals are strong, everything will definitely fall in place. Because upskilling, reskilling, all these YouTube gurus talking about all these things, right, they are not technically qualified enough to, even promote that. So how I see a college, why college is important, not these edtech companies, is because one, you as a college, you have filtration mechanism. So there are like 50,000 people apply, 5,000 people get in, and then this 5,000 people show up every day for 4 years and have been able to, one, they have the IQ to get into Vishwakarma. Two, they have the consistency to show up for 4 years and then come out of it successfully. So as a company, I'm looking for smarts. Two, I'm looking for somebody who can deliver value. I don't want a extremely skillful person, but he'll work only when he feels like it. So that is why college is important. EdTech companies, they admit anyone and everyone, because for them it's like a no cost model, right? I have a product, I just give a login, and for every login I charge a percentage. So those companies are just, with these unemployable people, they are just milking them, or in fact, I would say abusing them. That is what it is. So, what I would suggest from an industry perspective, right? You cannot skill them. So they have to be willing to learn, unlearn, relearn, and then constantly be willing to, keep on the lookout. That is what they would look out for in a fresher. And anybody who has got out of college without a job, 99% does not have any of those. And I, as a company, don't want to go and do it. I would much rather prefer somebody who will join me after 6 months but has the qualities. Because, dealing with these people is a menace. It's like cockroaches in your kitchen. Trust me. And their expectations are also, very, very unrealistic. Like, an IIT Bombay guy would have a reasonable expectation than a guy from a tier 3 college from a tier 2 city will have an unreasonable expectation. And given, now the kids who are getting out, their parents are also employed in technology, right? So they are like, hey, why do you want to take a job that is not even giving you this thing? Go to another course, do another MBA, and then, see if you can get a job with a starting salary of 10 lakhs. Are you even skilled? You did not get a job after BE. Then you want to, do an MBA. So, there are very, very small percentage that are good, but then, bulk of them are, bottom of the lot. Nobody wants to deal with the bottom of the lot, to be very honest. And I have hired a lot of freshers. The attrition rate is around 90%. And we being a startup, we hired a lot of freshers. They came in with nothing. 6 months we trained them. The moment they got the training, they left. All the money we put in was down the drain. Why would I want to deal with something like that? I would much rather pay a premium to a premium candidate.
Right. One more thing I would like to understand from Sharat and Biswadeep. Now, if we see IT product or IT services companies, so there is bulk recruitment. But when it comes to semiconductor industries, the number is very small. And these days, like what happening now, as Biswadeep mentioned, no freshers, at least a candidate with 2 to 3 years of experience. Then
Preferably no freshers. Yeah, no, I can't operate in that model of no freshers.
Right. No. Just as an example, I'm saying. Similarly, what happens? These companies are now their recruitment process is little different. They have changed it. Either they are taking interns first, They are
Yes.
testing them for a semester or a year, and then based on that, initially, as an intern, the very few number of interns like what they take, and then again they filter out, and then finally they give a PPO to again the PPO number is again very small, right? So just I would like to understand what Kaynes does and what HCL
In
does,
fact,
like, right?
intern conversion is something I would any day prefer for freshers
Right,
than just interviewing someone for 30 minutes.
right.
See, what time do we get when we do a campus interview? We usually descend on the campus around afternoon. We are given a slot in the early evening for a pre-placement talk. Then there's usually a written test, or the written test gets conducted before that. And then we do an interview. Now, if it's 3 to 4 people interviewing and there are 40 candidates, which means by the time and these go out in inside hours like 1 a.m. or 2 a.m. at night, each of the panelists is interviewing 10 people.
Hmm.
So you hardly get to know the student, especially know that student's work ethics, problem solving ability. You have a set of standard questions. Okay, define the timing diagram, show the timing diagram of a flip flop or something like that. And you hire or do not hire based on that. When it's an intern, the intern is kind of quote unquote living with all the rest of the employees. They're seeing his work attitude, they're seeing his regularity, they're seeing the way the person conducts in industry, and we make a much more informed decision. So I prefer intern conversion, and I've been very successful in intern conversion. The only time where things started dipping, and this is again, I would actually, because you're from the academia, I'd send a request back to the students, is during the COVID period when all of us went virtual. Interns used to themselves learn a lot by seeing us. And when I say seeing, it was visually. So I've seen cases where some of my tech leads would be sitting debugging. Interns would just be sitting behind him or her, observing what's happening. This tech lead is not consciously calling six into the come, let me teach you how to
Teach you
debug.
something, right?
They're watching him over the period of 6 months. And then they learn from that. In a virtual mode, tell me which tech lead will set up a Teams call and say, okay, interns, come and join this Teams call. Let me show you how to debug. We are already stressed. We have too many meetings because we are not
Right,
sitting
right.
across the
Yes,
table.
got it.
So the whole conversion rate dipped.
Right.
Now we are coming back to office, but I'm still seeing a trend of even interns coming and saying, I want a full virtual. It's actually not
Right.
helping them.
Them, right.
Right? So that's my thought process. I love internship. I love intern conversion.
Conversion.
And the more we do it, I think more we'll be able to get freshers. Sarat.
Yeah. So we're also hiring interns at Kaynes, and we have residential programs. We have an embedded systems opportunities. We have shop floor manufacturing opportunities. We are bringing them on board today while our OSAT is getting built. We're looking at the EMC shop floor guys to get trained on site in Mysore. And then when the OSAT comes, hopefully the cream of the crops will bump them up. We're considering OSAT a step up from EMS. Our embedded systems company is the next generation of our software developers, which are going to be actually booting up these boards. So we would love to bring in interns, get them excited, and let them go back to college and then come back to us if they have the fire in the belly and the right attitude, if there's a good connection with the manager. We're partnering with colleges and doing MOUs, and anyone who's doing the packaging courses, we are trying to get that database, and we do L1, L2 interviews, written test, and get them on board to Kaynes. These are people who have graduated and are now taking the diploma courses, not the interns. So we'll absorb them and get them into our EMS or our ChemSys, our embedded practice, in preparation for the OSATs. The laterals, as you know, the packaging industry is nascent. So probably what we're doing and what we're doing probably correctly is looking to Southeast Asia for packaging talent, actually. So Malaysia, Indonesia, our partner is in Malaysia. So we're going to be sending them also overseas for training for packaging specifically because we don't have the line yet.
Right.
So we're counting on our partners. I think that excites students. An opportunity to go for a foreign training program.
Absolutely.
I think the parents would say, "Good, beta. That's a good thing for you." It looks good on the resume that I was skilled and trained in packaging in a foreign country. You know, so we're doing all of these exciting things, and as we gear up. But internships is, I love internships because what we try to do is we try to structure short-term tangible output of these kids in 2 months, in 3 months times, but and not leave it open ended. Shadowing is naturally very important, but probably letting them give something where they can complete something.
Yeah.
So we try to structure programs, whether it's on the embedded side or even on the manufacturing side, short term, where they can complete something.
Right. Thanks. Yeah.
So yeah, finishing it off, right, Shripad. So I've hired people, especially in the early careers phase. HR's focused on early careers in companies like A.T. Kearney, McKinsey, Goldman Sachs, and all of that, where somebody's mandate is to hire people from IIMs and IITs, the top ones. Okay, and all they focus on is to get an intern, and their sole KPI on which they would be paid their variables is going to be on how much intern conversion they were able to do. The companies are more vested in converting the interns, and I see less and less of a trend where companies come to a college and talk to you for 30 minutes and then make a decision on that based on that 30 minutes and then get you on the roll. Still 3 months or 6 months is a short time, but compared to the 30 minutes that they get with the candidate, it's a much better thing. And also from an IT company standpoint of view, the IT majors are not hiring in bulk numbers anymore. They are laying off in bulk numbers. Now we have come to a state where institutions used to rely on 3 4 big recruiters to get 50 60% of their students placed. Now we've come to a situation where there are going to be 100 companies hiring 2 people each, and institutions have to maintain relationship with all these 100 companies so that they can get the same number. So I think the placement is also, the TPO's role also is evolving. At the same time, I see companies also hiring freshers more from an intern converted fresher than somebody coming and talking to you for 30 minutes and then doing it. I think that's the old model. The companies that are innovating understand the need for specialized talent, and that specialized talent is what they come to you for. So it was like mind blowing conversation, to be very honest. Learned a lot of things, and very very candid. It was completely unfiltered, raw, and kind of came out from the heart for all of you guys. And I was more of a spectator enjoying the conversation than moderating it. So thank you very much, all of
Thank you.
you.
Thank
Thanks.
you. Thank you.
So much.
Hey, thanks for watching Titans Talk today. I hope you had a really insightful session. I'm Gautam, your global CHRO who helps you buy, build, and rent talent across industries, across levels of experience. If you want to hire freshers or if you want to hire laterals, do get in touch with us with the link below, and my team will get in touch with you to take it from there. Looking forward to meeting you again in another episode.